Okay, so this is the very last of the lightning talks. I saved myself for last because I have the dictatorial decree. So I'm Corey Chivers, and my apologies to Shopify. I have no relation to the Chive, but my last name is Chivers. And this is just a talk I gave at Montreal Python, and I thought I would give, hopefully try to pare it down a lot to give a quick overview of it. It was 20 minutes at the time, but I won't take 20 minutes, I promise. And the talk was about from whale calls to dark matter, competitive data science with R and Python. Normally I'm a computational ecologist, but I do these things on the side. So what is competitive data science? Well, there's a company called Kaggle. Has anybody heard of Kaggle, just by show of hands? Okay, a few people have, but so what they're doing, according to their website, is they're making data science a sport, and they've been getting a ton of press. They're getting pretty huge. But so what they do is they post up data and a challenge about that data for all to see and to try to create machine learning algorithms that can solve some problem. And they post up a very well-defined performance metric, and everybody just competes on that performance metric, and whoever gets the best algorithm wins. So it's very cool, and it's also very addictive. And I've sunk a lot of time that I probably shouldn't have into these, so I'll just tell you a little bit about them. So the toolkit that I use, not surprisingly given the title, R and Python. But of course, that's a simplified view, so there's all kinds of things you're going to use. Obviously, there's lots of great modules in Python. I came to my grad work doing C++ originally, so I still go back to that as much as I loathe to do it. And then not so much in Kaggle competitions, you need to use this bottom half because you're provided with very clean data in Kaggle competitions. It's all very organized. You don't really have to munge anything, but in real data science, of course, we do a lot of munging, and I like to go to sed, grep, and awk for that kind of thing. And of course, I just can't talk about data science without mentioning Hadoop, though there's nothing to do with Hadoop in any of this. And so far on Kaggle, the data isn't of the scale that you would need to use Hadoop. So one of the contests that I tried out was this contest to find the whales, and it was a signal processing problem and then a classification problem. So the people at Cornell University have been dispatching these buoys with underwater microphones, and they're attempting to identify when there's blue whales in the vicinity of these buoys because it's also high shipping traffic lanes, and they want to avoid collisions between ships and whales. And so they need a classifier for determining whether there's a whale in the vicinity of these buoys. And so in the other talk, I had an IPython notebook, and I showed some of the analysis, but I'm not gonna do that. But I will show, I guess, just I don't know, a cool video of it. Let's see if I can bring that up. Okay, so what you get is audio files of these 2-second audio clips from these buoys. And I learned a lot about signal processing because it turns out, audio is weird and hard. But we need to translate that into something that we can apply machine learning to. And in this case, this is a spectrogram. So on the x-axis is time of the audio clip, and on the y-axis is frequency. And that's just kind of like a power map of the frequency over time. And what I'm showing here is the cases that were labeled positive for blue whale. And I don't know if you guys can see the blue whale call in there. Yeah, so he's cheating. Hadrian said he can see it, but he saw this talk in Montreal, so he's cheating. It's this little kind of hook-shaped thing here. They go whoop. They make this kind of really cool cool sound. And so those are the positives. I'm not going to show the negative cases, but they look like that. And we want to define a classifier which can find that little hook-shaped thing amongst the noise of potentially no hook-shaped thing. So I did that. I applied a support vector machine and a neural network. And what I showed in the IPython notebook was that these things are really easy to do with like scikit-learn and pandas. And they're just like amazingly simple to fit these things. Okay, so turns out this is a much longer talk than 5 minutes. So the other contest was find the dark matter. I should just say the punchline in that other contest was the people at Cornell, when they submitted this challenge to Kaggle, they were getting a score of 0.75, and this is this thing called AUC, and you want to get as close to 1 as possible. And within a couple of days of posting it up, people were having algorithms that were getting like 0.99. So it was really awesome, like, you know, the power of the crowd and a lot of very clever people. But there's also contests on Kaggle that don't really conform to this really standard machine learning type task, like a simple classification task. And that was this one, which I found really interesting, which was to find and map all the dark matter in the universe. And I'm not going to go into the details of it because it's about time for lunch. But it's very cool. I put the slides up so you can have a look at them. So I'll let you guys go to lunch. And thank you.